What do you like about corn?
It's cold. A big corn bit knobs. It has the juice. I got a more beautiful thing. It's cold. I can tell you all about it. I mean, look at this thing. When I tried it, I don't anything change. What a best thing about.
All right. So we are going to be talking about vocabulary today, and our lovely little corn kid, who's so cute, is going to be the theme of our vocabulary. So we're going to get started with some key vocabulary words. There's only 20 that we're going to look at today, and I want you to see if you can find the corn in each of our illustration slides. The first vocabulary word is this distributive property. This distributive property states that whether the numbers in parentheses are added before or after multiplication, the results are the same. We can distribute the numbers in the expression in different ways. The word distribute means to spread out. I would definitely recommend taking notes throughout these vocabulary words. I think that would be really helpful to write the word and a shortcut definition. You don't have to write it word for word, but that would be helpful. Here are some examples of the distributive property, and this slide has candy corn on it, and we'll just start with the candy corn. So this would be something like 72. I could distribute the multiplication addition of 72 by changing it to 5 times 8 plus 4 times 8. So basically I took 8 out and worked out the distributive property that way. So here's a 5th grade example. 36 times 4, we could change that to 30 times 4 plus 6 times 4. That equal should be a plus sign. But distributive property rainbow is here to kind of show you how you would distribute the 3 across these parentheses. But it's just a shortcut to solve more complicated problems. Mean is another really important 5th grade term. Mean equals average number. The mean can be found when we take a set of numbers, we add them all together and divide that sum by how many numbers were in the set. So the quotient is the mean. Mean equals average number. So to find average, we would take all of the numbers there. So in this example, the numbers were 2 and 2, 5, 6, 7, 8. And when we add them all together, we get 30. And then we divide 30 by 6 because there were 1, 2, 3, 4, 5, 6 numbers in the set. And so the mean or the average of these numbers is 5. There's another good example here. It says if you make 5 100s in class and then you make 1 0, what is the mean? So that would be 500 is your total, but we divide it by 6 because that 6th assignment, which was a 0, counts as one of the assignments. So one missing assignment will drop your grade from 100 to an 83.3%, right? So that just shows you how quickly those zeros can change grades. Did you know that your teacher uses mean every day to calculate your grades? Every single day. Also, the average ear of corn has 800 kernels in 16 rows. So a cob will almost always have an even number of rows. And then here's another example for you. So mean equals average number. All right, next slide. The word prime, we've talked about this quite a bit already this year, but a prime number is a whole number that only has 2 factors, 1 and itself. And the first 5 primes are 2, 3, 5, 7, 11. 2, 3, 5, 7, 11. It's really important to memorize those. It'll help you so much. We start reducing fractions and for lots of other applications in math. So prime numbers are usually odd numbers, but not all odd numbers are prime. And 2 is the only even prime number. Here's an example, 13. The only way to make 13 is 1 times 13. And then, of course, the opposite of primes are composite numbers. Composite numbers have more than 2 factors. So like 24, we can do more than just 1 times itself. You can make 24 by doing 2 times 12, 3 times 8, 4 times 6. Also, prime numbers, you can only form them using blocks one way. You can only make 1 row if you are using blocks, or you can make 1 array with them. And then the slide just has some prime brand corn on it. All right, a plane, geometric figure that has no thickness. So a plane figure is flat. Plane, and this is not to be confused with like an airplane. This is what we call a plane figure. So all polygons are plane shapes. They're flat. Solid figures like cubes, cylinders, cones, these are not plane figures, they're three-dimensional. And then I just included a chart with polygons on it, different polygons. Anytime you do a drawing, drawings are always plane figures because they are flat, just like my drawing of corn there. Range is another maybe new word for you, but range can be found by subtracting the smallest number in a set from the largest number in a set. So big minus little equals your range. And here they have a set of numbers. I like this example. They list them out. They take the largest number, 28, and the smallest number, 14. And when you subtract 28 minus 14, you get 14. So the range then is 14. If I'm the oldest person in our class and Elizabeth is the youngest, what is the range of our ages? So if I'm 42 and Elizabeth is 10, the range of our ages is 32. So that means there's 32 years between me and Elizabeth. And when I realized it was just big minus little, everything changed. Thank you, Corn Kid. He makes things more exciting. All right, array. Array is a line with a single endpoint that extends infinitely in one direction. So when I think about array, I think about the sun's rays, okay, the rays from the sun, and they start at the sun and then they continue on in one direction. So the ray here can be named like this with arrow PQ. So the arrow is on top of it because this ray is consisting of P and Q. Notice the arrow at one end. If it has dots at both ends, that's called a segment. So that would be a line segment where the other is a ray. So think about the sun's rays. And there's our corn in that one. All right. Mode. Again, we're talking about a set of numbers here. Mode is the number repeated most often in a set of data. Mode, most, mode, most. And I kind of emphasize the MO there. So in this sample, mode could be if you have your set of numbers and you always want to put them in order and whatever number you see repeated most often. So in this first example, I have 3 3s and 3 4s. So your mode is 3 and 4. Sometimes like this one over here, you just have one single mode. So on this one, I have the 3 repeated most often. So our mode equals 3 on this one. You don't have more than one, it's just 3. It is possible too to have no mode. I don't see a number repeated any more often than the rest in this last example. So we would say no mode. We would not say 0 because 0 could actually be a mode since it's a number. If 0 is not repeated most often, it's not the mode, okay? All right, equation. The key about an equation is it has to have an equal sign. If it does not contain an equal sign, it's an expression. But an equation is just a mathematical statement that shows that two expressions are equal. And so these are all examples of equations. And see the equal sign in each one. So 6 minus smiley face equals 4. 8 times corn equals what, right? As long as we have that equal sign, that's really important. What is an equation? This one shows these two little triangles equals these two little hexagons over here. As long as we have the equal sign showing that it's equal to something, that is considered an equation. Median. Back to when we have a set of numbers. The median is the middle number of an ordered set of numbers. And a good way to remember is median sounds like medium, which is the middle size of shirts or pants or whatever. And then median is also the actual name for the middle of a highway. So like that grassy little strip in a highway, that's the median. And take a look here. There's our highway. And the median's right in the middle there. That little grassy strip where you have cars going one way, cars traveling this way, and then cars will be traveling the other way. But the median is that little separation. So once you put the numbers in order, you find the exact middle, and that gives you your median. So median is the average of two middle numbers. If in the case like this one, we have two numbers in the middle, well, what comes between 4 and 4? 4. So 4 is the median. A lot of times you'll just have a single number in the middle, like in this case, it's just 6. 6 is the median, but the key is to put them in order. If you ever do get two numbers in the middle, just know that there's still only one median. You have to find the average, okay? You have to find the average of those numbers. Next is is ordered pair, and we've been doing these probably since third grade, but an ordered pair is made up of the x coordinate and the y coordinate, where you have two values written in a certain order where they're in parentheses. It helps us to locate a point on a coordinate plane for better visual comprehension. And so here, our little ear of corn is identified at 6, 4. So the parentheses are around the 6 and the 4. There's a comma. And over here, this plane, I guess, is located at 2, 8. But an important thing to remember is you always read the X before you read the Y. So on this one, you always read this X axis down here at the bottom. You read that number first, and then the number going up this way. X before Y, run before you can fly. So if we go over to X, the 6, the corn's sitting at the 6, and it's going across, it's sitting at the 4. That's why we have the ordered pair 6, 4. And again, those are in parentheses to help you keep them together. Expression. An expression is a math sentence. It has a minimum of 2 numbers or variables, and it has at least one math operation. So an expression can't contain an equal sign, or it's called an equation. We talked about that earlier. So I can't imagine a more beautiful thing. These math expressions, just no equal signs. And here's an example of an expression 4x plus 2. It turns into an equation when you say something like 4x plus 2 equals 100. Again, it's just an expression, like 3/8 plus 6/4 is an expression. So that's the difference between expressions and equations, just a matter of an equal sign. Perimeter is the total distance around a figure. The figure must have all straight sides, be a polygon, in order to find perimeter. So we're really just adding all the sides up. So in the first example here, I really like this one. The perimeter is the distance around a figure. And so they even give you the word start here. So if we were to find perimeter, we're going to add 10 plus 6 plus 4 plus 10 plus 10 plus 6 plus 4 plus 10. There's your perimeter. And I think about the word rim in perimeter because we know the rim of something is what's going around it. And so perimeter is where we add them all up. Remember, area is the inside of the figure. So perimeter is around it where you're adding them up, and area is the inside where we're multiplying in the case of a rectangle. So there's a little neon green line around this fence to show you perimeter is something like fencing. It could be border around a wall or maybe even lace trim, okay? And then here I had to include, what's the perimeter of this cornfield? So it would be 10 plus 6 plus 8 for that one. You just add those together. Probability is the mathematical chance which an event is likely to occur. So it's measured by the number of probable cases to the whole number of cases possible. It can be written as a fraction, decimal, or percent. And here's some probability. So probability has 5 possibilities. Probability can be impossible. It can be unlikely. It can be even chance, which is also called equally likely. Could be considered likely or certain. So for example here, probability of rolling a 6 on this dice. Well, I know there's 1 6 on the dice out of 6 total options, so that probability is 1/6. Probability of getting heads on a coin. Well, I know one side is heads and the other side is tails, so we have a 1 out of 2 or a 50% chance on that one, or you could even say 0.5. But probability is just the likelihood or chance of something happening. So if I were to ask you, what are the chances of rolling a 7 on this dice? I would say impossible. There's no 7 on this dice. Spinners are often used for probability too, and of course I had to put some corn on our spinner. So this was the different stages of the corn life cycle from seed to being used for human consumption or animal consumption. So spinners are used a lot, and probability is always between 0 and 1, 0 being impossible and 1 is certain. So a certain example would be something like, what is the probability I will land on a number on this dice? It's certain you're going to land on a number, right? So that is where the terms certain and possible come in. All right, obtuse angle. An obtuse angle is an angle that measures greater than 90 degrees but less than 180. And here's an example. The obtuse angle's nice and open and wide. Well, acute angle, a cute little angle, he's less than 90 degrees, okay? So this is smaller than 90. And we know 90 degrees is a perfect right angle. So 90 degrees, if we went straight up and over, that would be a right angle. So you can tell acute is less than that, where obtuse would be more than that. I used this guy's belly here. I thought this was funny because obtuse starts with the same two letters as obese, which means very overweight. Think of obtuse angles as obese to help you remember them. I was looking at his belly thinking, oh, that's a good idea. That's greater than 90 degrees. And then, of course, we had to do some obtuse corn right here. It is obtuse. It is obtuse. Okay. Next, inverse operations are opposite operations that undo each other. So they're just the opposites of one another. And here's some examples, like the opposite of multiplication is division, the inverse of addition is subtraction, and vice versa. And he says with inverse operations, everything changed. Yeah, inverse is just, you can even think about the word reverse, opposite. Parallel lines are two lines in the same plane that are equal distance from each other and they never meet or touch. They can be both vertical and horizontal, but they can also be diagonal, all different ways, so long as you have lines that go on in one direction and never touch. And there's lots of real life examples like these highline wires, of course, kernels of corn right here, they run parallel to each other, and then the train tracks. Another way to remember parallel is the two L's in the middle of the word. So parallel is spelled with two L's. And look, those L's are parallel to each other. That's a good way to help you remember the word parallel. Perpendicular is another geometry term. It's where two lines intersect to form a right angle. And here's some examples of perpendicular lines. And they have right angles in each one of them. This little tiny box that they put in corners of right angles is actually a geometric symbol. That lets you know that, hey, I meant for this to be 90 degrees. I meant for this to be a right angle, even though I'm not a perfect artist, or maybe I didn't get them exactly straight. The box is for people like me who can't put their corn exactly straight to make a 90-degree angle, but I want my audience, my students, to know that that's what I meant there. That's an actual geometric symbol that we use. Also, perpendicular lines do not have to actually intersect, like pass completely through each other. That's not necessary. As long as they meet at a point and form a right angle, they are perpendicular. And there's lots of real life examples of perpendicular lines everywhere. Reflection is known as a flip. A reflection is a mirror image of the shape, and I emphasize the letters FL in reflection and the FL in flip. So reflection is just a flip. And I included some reflections here. This corn is reflecting across this glass. And then more mathematical is when we have a line of reflection. In this case here, and I can see that the triangle is reflected on both sides. And like these Tetris pieces are reflected across this line. And I thought this was an interesting kind of concept. They have this 1, 2, 3, 4, 5, this pentagon, and it is reflecting across the water upside down. So double meaning reflection on that one. So reflection is a flip. You're just flipping it over. A rotation is a turn, and that turn needs to be around a fixed point. So I emphasize the letter T in rotation and the T in turn to help you remember that. And there we go. Rotation is when something actually rotates. The letter F here I feel like is the best example because it has a definite top and bottom. And so the top here you can see when it rotates, the top's now down here, but it travels around a fixed point. And here's another real life example, this bicycle tire. The spokes create these triangles, and as this turns around, there's this little axle inside of the bike wheel that causes it to rotate. That point is also called center of rotation. Okay, the center of rotation. And of course, I've got to have some corn do a rotation there. Variable, a variable is a symbol, usually a letter, standing in for an unknown value in an equation or an expression. So a variable can be anything unknown. A tree, a corn kernel, or a box can be a variable. So a variable is most often in math, a letter. And that is one of the reasons why as fifth graders, we kind of quit using time signs. We don't see a whole lot of time signs anymore because time signs really look like the letter X. So we have to be careful. We use dots or we don't use anything at all. And we say no sign by, you multiply. And so variables can be anything, a box, the trees, the corn kernels. It's just some unknown value that they've used something else to represent it. Okay. Well, I hope you have a corntastic day and have enjoyed learning some vocabulary, and I will see you next time.
You really appreciate that whole world when you love something. If you anyone loves corn, if you come to me, I can tell you all about it.